In this video, we are going to learn the work and energy. What is difference between work and energy? So, what is work? As you can see here, work is energy transfer by the force. Work is a measure of energy transfer that occurs when an object is moved over a distance by an external force. And what is energy? Energy is ability to do work. It may exist in potential, kinetic, thermal, electrical, chemical, nuclear, or other various forms. Let us learn in details. Let's imagine a block, and it is acted upon by external force F. Due to this external force, let's say the block has moved the distance d. When the block is moved by the distance by external force, it is said that work is done. We can understand the work by this formula. Work is equal to force times the distance the block has moved. Let's say force is 10 Newton and the block has moved by distance of 5 meters. So, how much work is done? Work W is equal to force times the distance d. So, work is equal to 10 into 5, that is equal to 50 Newton meter. Newton meter is also called joule, which is also the unit of energy. Let's say force is 20 Newton and the block has moved by distance of 5 meters. So, how much work is done? Work W is equal to force times the distance d. So, work is equal to 20 into 5, that is equal to 100 Newton meter or joule. We know, force is equal to acceleration times mass. So, F is equal to acceleration times m. We can rearrange and say acceleration is equal to force F by mass m. We are going to use this in next equation. Let's say Vi is initial velocity and Vf is final velocity just before block has come to rest. Let's imagine there is no friction. Since the block has moved by the distance d, there must have some acceleration. Let's say it is a. We all know the kinematics equation. Vf square is equal to Vi square plus 2 times product of acceleration and distance. So, here initial velocity is 0. So it will be Vf square is equal to 2 times acceleration, times distance d. Let's replace acceleration by F by m. So Vf is equal to under root of 2Fd by m. F times d is work. So, Vf is equal to under root of 2W by m. We can arrange the equation. Vf square is equal to 2W by m. So, work W is equal to half mVf square. Tell me what is half times mv square? It is nothing but kinetic energy. So, we can say, work is equal to energy. So, work W is equal to half times mass m times v square. Here, we can replace work W by product of force F and distance d. So, it becomes, Fd is equal to half mv square. If we know the velocity and the mass of body, we can calculate how much work is done to achieve the known velocity. Let's say, velocity of body is 10 meter per second and mass of the body is 20 kilograms. So the equation becomes Fd is equal to half times 20 times 10 square. It becomes, Fd is equal to 1000 joule. So, in this way we can find out the work required to move the body at particular speed. Now, let's say a block of mass m is to be lifted by force F to the height of h. You can imagine the case of elevator. So tell me, how much work is required? Let's first calculate the force required to pull it. Force is equal to mass times acceleration. So, F is equal to mass m into g. G is acceleration due to gravity. Acceleration due to gravity is in downward direction. So to lift the block, at least acceleration that is equal to g in the opposite direction is required. So, F is equal to mg. Therefore, we can calculate the work required to lift the block by the formula of force into distance. So, W is equal to mgh. Let's do this exercise. Suppose mass of block is 20 kilograms, and the height is 20 meters. So, work W is equal to 20 kilograms times g times height 10 meters. Here g is 9.8 meter per second square. So, work W is equal to 20 times 9.8 times 10, which is equal to 1960 joules. Where the 1960 joules of energy gone? As we know, energy can neither be created nor be destroyed. It can only transfer from one form to another. That's the law of conservation of energy. So, here in this case all the energy gets transferred into potential energy. So, we can say the same differently, like block has potential to come down. It has gravitational potential. Let's learn the same in another example. Let's say I am holding the block at height h. So it has potential energy. Potential energy is equal to mgh. So here in this case potential energy shall be 1960 joules. Now, let's say I drop the block. When the block has fallen on the ground, the potential energy shall be 0, as you can calculate the same considering the height 0. So where that potential energy has gone? Just before the block has fallen on the ground, it had some velocity. The potential energy got converted into kinetic energy. So, if we want to know the velocity of just before it touches the ground, we can easily calculate it by using above concept. So, kinetic energy is equal to half mv square. When we know the kinetic energy, which is equal to potential energy, which we have already calculated, we can arrive at the velocity of the block. Subscribe Extra Class Academy for more educational content.